The James Webb Telescope is set to upset our insight into the universe, and without a doubt, the $10.1 billion gadget is more than satisfying this aggressive task. After all, the Webb revelations of the last 2.5 years have over and over shown us that so much of what we assumed we knew about the universe is just wrong. Not only are there galaxies out there that, according to our understanding, shouldn't exist by any stretch of the imagination, but there are also immense early black holes of a mysteriously high mass and, not least, an exoplanet on which life may already be thriving. Look for something incredible, or rather, anticipate the incomprehensible. The James Webb Space Telescope has already added a few early systems to the star charts that completely topple our current standard model of cosmology. The first cosmic seismic tremor sent shock waves through the cosmic community in spring 2023. Webb had found 6 worlds that existed only 500 to 700 million years after the Big Bang, but they were already as massive as our Milky Way is today. Scientists had only anticipated child universes for this early time of the universe, but instead they were confronted with incredibly monstrous designs, each containing more than 10, and in one case, significantly more than 100 billion solar masses of stars. The fact that these cosmic premature infants thus earned the ignoble moniker universe smashers is again due to the fact that, rigorously speaking, they shouldn't exist. Well, that is, if the universe were to play by our theoretical rules, making it conform to our models. There just wasn't enough normal matter so soon after the Big Bang to form so many stars in such a brief time frame. Alternatively, this implies that the presence of such huge early galaxies can be explained by the fact that the matter density in the youthful universe was 2 to multiple times greater than our established assumptions predict, or perhaps that the galaxies formed in a way that is totally obscure to us. One way or another, the standard cosmological model is extended as far as it can go. And consistent with the adage, one incomprehensible system find is seldom alone. In February 2021, Webb had already tracked down the next world that appears much too large for its early development date. This time, the design was home to 4 times as many stars as the Milky Way is today, 11.5 billion years ago, with many of the blazingly bright galaxies most likely having formed another 1.5 billion years before they were seen. How is it that this early black hole weighed more than 1 billion solar masses? Different objects, same issue. Very much like the early galaxies, the very large black holes found by Webb aren't anything more than a cosmic impossibility. For years, scientists expected these colossal gravitational beasts to only exist at the centers of galaxies, growing much like their cosmic environment itself, by accumulating more and more mass due to their immense gravity. The matter that falls onto a black hole forms a rotating hot accretion disk that constantly feeds the object at its center. In the case of very massive black holes, those with millions or even billions of times the mass of the Sun, an active cosmic core, a so-called quasar, is created. Simultaneously, the energy of the accumulated matter is released by the quasar, somewhat in the form of radiation. While this radiation simultaneously applies counterpressure on the falling matter, the system stabilizes itself, essentially dialing back the further material attack. In other words, black holes can't grow for arbitrary reasons at an incredibly fast pace. So, how is it that so many early instances of these objects are so mysteriously large? Well, it is possible that black holes somehow manage to consume gas much more efficiently than their modern counterparts. It was exactly to test this hypothesis that the specialists at the Maximum Board Organization for Space Science used Webb's mid-infrared instrument, MIRI, to study the most distant known quasar at the time, designated with the scientific name J120+0641. This object is a functioning cosmic core that existed during the astronomical dusk, and hence only about 770 million years after the Big Bang. At the end of the study, however, the researchers had to conclude, somewhat in disbelief, that the youthful quasar, despite having a mass of over 1 billion solar masses, was, and I quote, surprisingly typical. In the end, the early mass beast had no feeding mechanism that was noticeably different from that of modern-day quasars. At the end of the day, there were supermassive black holes with fully developed feeding mechanisms when the universe was only 5% of its current age. Thus, The researchers had to content themselves with the discovery that the vast mystery had only expanded further. Webb's abnormal revelation in the Orion cloud. Did you know that there are planets out there that break the traditional mold and don't orbit around a host star? These planetary rebels are known as rogue planets, and these are either planets that were ejected from their home system after their formation or celestial bodies that were never gravitationally bound to a star in the first place. And indeed, in the fall of 2023, Webb identified a series of extraordinary objects in the Orion cloud that take the usual rogue planet design to the absurd and appear there in pairs, about 1,350 light-years from us. The Orion cloud is one of the most active star nurseries in our cosmic neighborhood. Moreover, in the past, scientists have been able to identify rogue planets here in detail. However, these objects are especially massive celestial bodies, known as Jupiter mass double objects, or jumbos for short. Yet how could it be simply the 40 free-drifting jumbos viewed as by Webb's close-to-infrared camera close-to-cam in the Orion cloud really meet up in coordinates well? It just so happens the specialists have figured out how to reveal some essential qualities of the planetary matches as a feature of their assessment. As per this, we are managing grandiose youthful firearms that are only 1 million years of age and have surface temperatures of around 1,000 degrees Celsius. Sadly, we can conjecture about how the gigantic wound up in the Orion cloud. The main clarification is in light of the suspicion that the items were framed in a locale of the Orion cloud that was excessively poor in issue to structure genuine stars, since there was not enough hydrogen here for heavenly development and the start of atomic combination. The jumbos could in this way exemplify a section of bombed stars. On the other hand, there is the hypothesis that the divine bodies initially filled in the ordinary manner to become Jupiter-like gas Goliaths and were at last shot out from their home framework by an obscure occasion. And despite the fact that the specialists underscore that they consider this speculation to probably be the more likely one, they additionally concede that they don't know why the heavenly bodies were isolated from their parent stars in matches. Different specialists, on the other hand, think of it as conceivable that the jumbos are in no way, shape, or form a grandiose mishap, but that they started from a basic component in the Orion cloud that is presently still totally obscure to us. Since, who knows, perhaps the huge haze of interstellar gas not only goes about as a persistent star plant, but also as an enthusiastic large maker. If the hydrogen thickness here is constantly distributed in certain districts so that it can never produce a genuine star, but always two gas planet-like objects that are gravitationally bound to one another, we would never again discuss a happenstance but instead a decent example. How Webb found a small-scale space rock. When we hear the word space rock, we quickly consider possibly lethal rocks measuring many kilometers across, but they can be much more modest. In February 2021, Webb, as a matter of fact, found an item that was small in a cosmic setting, and in doing so, once again, it reminded us that many discoveries are simply made possible to invigorate by discovery and chance. The group, led by Thomas Muller from the Maximum Board Organization for Extraterrestrial Physics in Gering, originally wanted to take adjustment pictures of Space Rock 10920, 1998 BC1, to test the performance of some dirty channels. Anyway, the specialists then accepted that their endeavor had failed because the noticed space rock was basically too bright for this. The specialists were, therefore, even more shocked when they had the option to detect the small-scale space rock after all while analyzing the information exhaustively. It is an object just 100 to 200 meters long in the space rock belt between Mars and Jupiter, which was captured on film from a distance of more than 100 million kilometers. Before the launch of Webb, noticing space rocks of this humble size was hard, no doubt. But the unparalleled awareness of the most powerful space telescope ever assembled is opening up entirely new roads of examination into these items. This is especially significant given that the space rock belt is also viewed as a sort of regular time capsule, with many materials from the beginning of the planetary group still circling here. Concentrating on its parts can consequently assist us with looking further into the birth and development of our home world, and to lay out a complete picture, we now need to investigate even the smallest bits of this astronomical mosaic. The potential biomark of K218b. It's probably the most important question for mankind. Are we alone in the universe? Given the great many developments in the universe, is it even conceivable that Earth is the only divine body that has developed life? Well, the stupendous discovery that Webb has made on the exoplanet K218b could assist us with at long last getting a little closer to the solution to this enticing inquiry of life. Found just shy of 125 light-years from us, this outsider world is associated with being a planet that is a completely evolved sea world that, up until this point, only exists on paper. But that is not all. Because of Webb's close speech, we now also know that the air of the planet contains dimethyl sulfide, DMS for short, a sulfur compound that, on Earth, is regularly produced by living things. The reality that the presence of our extraterrestrial neighbors has not yet been formally declared, notwithstanding all this, is basically on the grounds that the captured DMS signal was not particularly strong. Also, it was only revealed when the specialists assessed the Webb data in a clear manner. To put the aforementioned informational collections to the test again, the specialists, therefore, chose to reconstruct the water planet and its conceivable organic chemistry using a few models. In these, they recreated the thought of a planet crossing sea and climate, and then they checked how much DMS the creatures there would need to produce for it to accumulate in the flammable gas envelope. At the same time, the scientists tested how rapidly the DMS is separated again due to radiation and in which areas it tends not to be expected. The main outcome was the interesting finding that biogenic sulfur gases can indeed accumulate to detectable levels on hydrogen-rich planets like this one. However, this would only be possible if the organic entities of K218b are entirely more enterprising than their earthly counterparts. This is because they would need to produce an amount of DMS that is multiple times higher than on Earth. This is for the simple reason that a large proportion of DMS is quickly separated again by photochemical disintegration under the impact of IR radiation. Anyway, if the concentrations are higher, which wouldn't be surprising for a sea planet, the degradation products of DMS provide a protective effect. The corresponding molecules like DMS and methanol act as a sort of safeguard for the lower atmospheric layers and prevent further DMS loss. Luckily, however, such hypothetical models are by all means not the only method for solving the DMS mystery. Despite this, for the subsequent investigation of K218b, the researchers need to switch to a different instrument of the James Webb Telescope, since the DMS signal captured by close speech appeared in the spectral line at a frequency of 3.4 micrometers. It overlapped with the methane signal. In order to separate the two atomic values more clearly from one another, the specialists will, therefore, rely on Webb's dirty spectrometer. This works in the mid-infrared range and, therefore, precisely in the range where DMS and its products leave their traces. Feel free to ask for further assistance.